Yeah, ma'am.
Okay. So let's start with the machine translation. So this is the first topic of your fourth module. So actually, Miss, we'll discuss little bit about the history of machine translation. So before the computer has evolved, like before the computer has discussed with the public, before that machine translation was explored. Okay, so you can think of how old is this technique. Okay, so machine translation was one of the first application envisioned for computers. Okay, so there is one American scientist, mathematician, Warren Weaver. Um, he said, one naturally wonders if the problem of translation could conceivably be treated as a problem in cryptography. Okay, so here he wants to relate you this machine translation problem with cryptography. Okay, so how is relating? When I look at an article in Russian, I say, so what he's trying to say here that he is an American, so his native language is English. Okay, so when a native English speaker looks at an article in Russian, or you can say in any foreign language, okay, which is not its native language, his native language, then what he say? This is really written in English, but it has been coded in some strange symbol. Okay, and I will now proceed to decode. So this is how he's trying to relate this machine translation with cryptography. Like in case of when we have discussed noisy channel model, so in that situation, what we were doing, we had a channel, means we had a channel, and using that channel we were trying to transmit source and means source data into target form. Okay, so the same thing he is telling that this Russian text is actually written in English, but while transmitting it through the noisy channel, it is got encoded into Russian form. So Russian is like encoded form of English. So that's how you can relate. Now, so the first statistical, first, or you can say first machine translation demonstrated by the IBM company, IBM, in 1954. And what they have demonstrated here, sorry, with a basic word for word translation, means one word in a sentence got translated into another word, means in other language. So word for word translation they have demonstrated. So what is actually machine translation? So we all know that automatic conversion of text from one natural language to another natural language. Okay, so one example is given in English. Be the change you want to see in the word. So Hindi conversion of this word is वह परिवर्तन बनो जो संसार में देखना चाहते हो. So this is like one of the actual correct conversion of this English sentence. So suppose this is the source language uh, sentence. Okay, so source language is English. Now you want to convert it into Hindi. So your Google is translated the given source into target one is वह बदलाव बनो जो आप दुनिया में देखना चाहते हो. Okay. Similarly, when Google is used to translate this English into Bengali, so some sentence means the same conversion has done in Bengali form. Similarly for Tamil and Telugu. So this is some example of machine translation performed by using Google Translator. Okay, so why we need to study machine translation? And so it is actually one of the most challenging problems in natural language processing. Okay, and it actually involves all layers of NLP. So NLP is actually performed at multiple levels. So this problem, machine translation problem, for solving this kind of problem, you need to involve all the layers of NLP. Okay, and theory and techniques in MT are applicable to a wide range of problems like speech recognition, synthesis, and many more. Okay, now there are some challenges involved in machine translation. So, what are they? So, actually, here what we are trying to do, we want to convert one language into another language. We want to convert one text written in one natural language into another natural language. So we know that each language is different. They have different grammar rules. They have means different characteristic in different terms, you can say. So language divergence. This is what language divergence. So how they are diverging in the sense of word order means, like in Hindi, the word order is subject, object, and verb. Whereas in English, the order of the words have like subject, verb, object. So you can see that the very common language for us is like Hindi and English. So in that, the word order are different. So you cannot directly convert any text written in English into Hindi if they have different word order. So first of all, you need to predict the word order of the given language. Okay. Second is the preposition. Differences in the preposition. So how this preposition is like in case of Japanese language. So like when you like there is one phrase in English like to John. So when you convert this into Japanese, it will be converted into so to John. So to is like preposition in this English phrase. Whereas when you want to convert this into Japanese, so it will convert into postposition like John to. So this is the difference. Means in the different languages they use, some languages use prepositional system, some use postposition system. So you need to identify that also. And then there is like inflection properties also. Inflection property also vary from languages to languages. Like in case of Spanish language, there is different form of inflection is there, and in different language there is different characteristic used for inflection, for performing this inflection characteristic. So these are the differences. So first you need to identify the characteristics or properties which are particular to a language, and then you can perform the translation. Okay, so the ambiguity, yeah, one more difficulty is like ambiguity. So ambiguity, the same ambiguity we have studied so far, like same word, multiple meaning. Can you give an example for this one? Same word, multiple meaning. This is like very
Ma'am,
common.
bank, ma'am,
Yes.
bank, bank, ma'am,
Multiple meaning.
bank. It may be river
Yeah, yeah.
bank or
Yeah, correct. So this is ambiguous word again. So it depends on the context. So if you have ambiguous word and you want to convert that ambiguous word in one language into another language, then it will not be translated correctly. Okay, so this is the problem. Again, same thing like same meaning, multiple words. Okay, so all this kind of ambiguity creates problem while performing the translation. Okay, now word order we have already discussed. So when you have word order, different word order in different languages, so first you need to identify that. So because of the different word order, you have different phrase structure grammar, means grammatical rules are different. So that means first you need to identify the correct word order for a particular language. Okay. Now, one example is given for translation of one sentence written in English to a French. Okay. So the English sentence is Mary did not slap the Greenwich. Mary didn't slap the Greenwich. So the corresponding French sentence is given. So this is how you perform the machine translation. So now uh, we need to identify which English word is translated into corresponding French word. Okay, so like Mary in English, Maria in French, something like that. Maybe I'm not pronouncing it correctly. So that correspondence translation is known as alignment. So that is what we call it word alignment. So it is very important. This is very important topic to understand is while performing this machine translation, first thing is to identify the alignment. Which word in a source language is converted into corresponding target language. Okay. So this alignment is nothing but mapping between words in one language and the other. So here you can see that this Mary, means the lines are represented here. This Mary is the corresponding word is this one. Didn't is represented here. So here you can see that this slap word is represented with these three words. These three words in French. Okay, so this is also one of the problem, like one to many mapping. One to many. Okay, so it is not like that every time one word in one language is going to be converted into particular one word in other language. So there is like one to many mapping, and sometimes you will find that many to one mapping, and sometimes many to many. So this is word alignment challenge. Okay, so for correctly predicting the word alignment, this is also, so for this also you have different algorithms. Okay, like here okay, now here you can see one more keyword, bilingual dictionary. Can you tell me what you can understand with this word bilingual dictionary?
Ma'am, multiple language dictionary, ma'am.
You are almost correct. Not multiple languages.
Two languages.
Bilingual means,
Two languages, ma'am.
yeah, only two language. Okay. So multilingual means multiple languages, but bilingual means only two language. Monolingual means one language only. So generally we have bilingual dictionaries like English to Hindi conversion. Okay. When English to English, that is monolingual. English to Hindi, bilingual. English to French, bilingual. Okay. So here, so is having a bilingual dictionary, is it sufficient? What do you think? Means with the knowledge of bilingual dictionary, can you perform all type of translation? No, you cannot. Like in if you take an example of country like India, where more than 30 languages are here. So if you have only bilingual dictionary, then you cannot translate. Suppose you have a bilingual dictionary for English and Hindi. Now you want to translate English into Tamil, then you cannot do that. So for that, you need to have a multilingual dictionary. Okay. So similarly, suppose you have English to French and now you want to convert English to Hindi, that is not possible. So for that, you need to have a multilingual dictionary. So that is a different task. but now you need to understand whether which one is more efficient. Okay, so here you can see that, yeah, first example here. In the first example, John loves Mary. Okay, so like 1-to-1 alignment is here. 1-to-1 alignment. Okay, one word is aligned to another in the another other language. Okay, whether in this example, John told Mary a story. Okay, so here this is 1-to-1. This is what? 1-to-many. Okay, this is okay. So this is different kind of alignment. This is called as reordering. Means here till now these many words are converted in same order, like you told, and these words in different language. Whereas this Mary is not ordered, means not written in the same order, means not converted in the same order. Okay, so that's why it is known as, this is a different property and called as reordering. Okay, so this is a different thing. Now after that they are again aligned, 1-to-1 mapping. Okay, now till now you have seen 1-to-1 mapping and 1-to-many mapping. Now in this example you can see many to one. This computer scientist is converted into single word, and that is informatician. Okay, so this is how you can see in different languages means different characteristics they have. Okay, and here this is not present, means if you have some context like this in English, so when you are going to convert that sentence into French, you are not having any alignment for this word. So if you have any word in source language which is not aligned to any other word in the target language, so this is source language, right? And this is the target language. Then what we were discussing, that if you are not having any word for source language, means there is any word in source language which is not converted in the target language, then we align it with null element. Okay, we consider that this is aligned with null element. Okay, just for the means sake of the simplicity, okay, we just simply tell that this word is aligned with null element. Right, now so we have seen all kind of
Ma'am,
yes,
but how the algorithm will map this alignment? There will
that we
be
will
difficult, no?
yeah, that we will see further. So till now we are simply studying in terms of theory, how the things are happening, what are the challenges. After that we will see that how the algorithms will work for that. Okay, fine. Okay,
Yes, ma'am.
so now we
But
have understood. Yes.
but ma'am, the knowledge base that we had should be a map with a meaning also, no? The meaning should not be changed. Suppose computer scientist two words, then the mapping may be different, but it is also only showing the one informatician, no? How this is done?
Mm-hmm. No, can you repeat the question?
Suppose, ma'am, there may be the multiple mapping for a computer,
Mm-hmm.
and this for a scientist there may be a multiple mapping for a scientist also.
Mm-hmm.
And when the two
So
words is combined,
see.
yes, ma'am.
So that's why I'm telling you that in further slides, I'm going to discuss how this kind of translation being done using probabilistic approach. Okay,
Okay, ma'am.
this is
Okay, ma'am.
this is what I have told you initially. This machine translation is not a easy task. This is one of the challenging problem of NLP. Okay, so for solving this kind of problem, there are various number of algorithms. Okay, so if you try to understand this in terms of n-gram model which we have discussed, so you know that whenever it's not like that ki computer, if there is, suppose John is a computer scientist, So computer and scientist, how many times this word is occurring in the given corpora, that is assigned some probability. With that information, you can tell that this word is more frequent, or uh, co-occurrence for this one is highest. Whereas, and similarly, you have corpora, you are going to have parallel corpora for computer scientist. Whenever you will see in your corpora that computer scientist is aligned with informatician, so for this kind of pair, you will have highest probability. Okay, so with this knowledge, you are going to perform the translation. So I just gave you one example how the things will happen. Okay, in the sense of probability. Okay, now we'll see further. Okay, so all these things we have seen. Okay, yeah, here one more example is given. Okay, so that is also we have discussed. Now, lexical divergence means in terms of lexical, how they are ambiguous, how ambiguity is creating problem. Like different sense of homonymous words generally have different translation. So homonymous words, can you tell an example for that? What is homonymous word? Yes, homonyms we have studied. You people have your viva tomorrow, right? So when two or more words have same sound and maybe have same spelling, okay, but have different meaning in different context. This is homonymous word. Like bank, in terms of river, it is having different meaning, and bank in terms of finance having different meaning. So this means same word, means same spelling is there, and it is converted into different. So English to German conversion. So for German, it means in German language you have different word for that. Okay, so this is one of the challenge. Now there is challenge with polysemous word. Polysemous word means same word but different meanings. Same word, like I know that he bought the book, so you can see in different language this red color, blue color, green color means they are different translation for the same word. So what does that mean? You need to recognize uh, which what is the meaning of that particular word. Means you need to disambiguate the sense associated for that particular word, which we have already discussed how we can perform the word sense disambiguation. Okay, with that knowledge, means that knowledge need to be incorporated here. Okay, so everything is linked, whatever we have studied before. So similarly, like uh, river that flows into ocean, okay, have different meaning. Like for that one also, we in English we have word river, whereas in French it is different word, something like reverie. Some, I don't know what is the pronunciation. So the blue one is representing the uh, word in French. You can see river that flows into ocean and river that does not flow into ocean. So for both the things they have different word, whereas in case of English you have the same word. So that is the problem. Okay, so in different language you have different words for different meaning. Okay, so all that need to be considered. Okay, all that thing. So yeah, now we are going to discuss about machine translation approaches. So before this standard approaches, we'll see what was the basic approach uh, used by the researcher for performing the machine translation before this rule based and data driven machine learning based approach. Okay, so before that there was one approach known as direct approach. So it says start from the beginning of the foreign sentence and then look it up in the dictionary one word at a time. What that mean? What that means? It tells you that whatever sentence you want to convert, okay, whatever sentence you want to translate, you just pick one word from that sentence from the beginning and the look into the bilingual dictionary, or if you have multilingual dictionary, then use that dictionary and convert that but one word at a time into target language. Okay, so that was the direct approach. So in the direct approach they were not considering any disambiguity, any information which we have discussed before, like this one means the word order and the preposition, postposition, semantic information, lexical information, nothing. They have not considered any information. They have simply converted on the basis of dictionary information. So what will happen? So actually this approach was tried in 50s and 60s, okay, when there was no resources, means like they have not any machine learning techniques and nothing like that. So that was and at that time this was the best approach. Okay, so in this, okay, so once after developing their system, the researcher has tried to evaluate the performance of their system. Okay, so there is one example. They have converted one sentence into Russian, English to Russian, and for the evaluation how correctly it is converted, because they don't know the Russian, so they converted Russian into English. So that if this converted English, if it is equivalent to the actual English sentence, then the generated system is correct. So what was the English sentence for them? It was the flesh is weak, but the spirit is strong. This is the example sentence they gave for evaluating their system. So so this sentence, the flesh is weak, but the spirit is strong, is converted into Russian, and then Russian is converted back into English. And the converted English is the meat is rotten, but the vodka is very good. So the actual sentence was something else. So this is what very bad translation. Okay, so then they realized that what is the issue here, and after that they started solving the problem. Okay, so this was the direct approach. Now here you can see that knowledge based approach and the data driven based approach. So knowledge based approach is also called as indirect approach. So direct approach we have already seen, and these are indirect approach. So here we will see what is transfer based MT approach. So transfer based is actually a form of rule based machine translation. So in this method you have some set of grammatical rules that apply to different pairs of languages. Okay, like in French. So first of all you need to have the knowledge of grammatical rules for different languages like source language and the target language. You need to have all the grammar information. Like in French, adjective follows the noun. Okay, and in English, noun follows the adjective. So this is different grammar information. They are not having the same grammar characteristic. So you need to have that information. And according to that, so you need to identify the adjectives and nouns in a sentence, and you can translate them in the right order. So this was the transfer based technique. Okay. Another technique is interlingua based. So what is this interlingua? Interlingua is a keyword. So interlingua is some sort of semantic representation of the text. So semantic representation, okay, you need to note it down that it is some sort of semantic representation of the text that is not dependent on the underlying language. Okay, so um okay, so how it can perform the translation? So when you want to translate, okay, let's say the foreign language into some logical form. Okay, when you want to translate one foreign language into logical form, okay, suppose in the first order form, then you can use some uh, generation technique to translate back from that interlingual representation to your target language. Suppose you have one sentence, this is a blue house. This is written in English and this is a source language. When you apply interlingua here, so it will be converted into house and one logical operator, blue. Okay, so this is what interlingua representation. So nowadays these two techniques are outdated. These techniques are not used at all. But I'm giving you a brief introduction with this technique so that you will be aware that what was the problem in this technique and how the machine learning based techniques are evolved. Okay, so yeah. Now these machine learning based approaches can be understood using this vacuous triangle. Okay, this is nothing but a, in the form of a triangle you can see here. So first you have, like, you need to perform morphological analysis. So yeah, at the starting of this lecture we have discussed that machine translation involved all the layers of NLP. So what are the layers? Morphological analysis, semantic analysis, syntactic analysis. Okay, so all this information are involved here. So first you will have word structure, you need to convert word into word form, then you need to incorporate semantic information, syntactic information, okay, for correctly translating one language into another. So this direct transfer we have already studied. So the syntactic transfer means semantic information need to be captured, means what is the syntactic information present in the one language, means the source language, and what is the syntactic information in the target language. Like English to Spanish, when you want to convert in English sentence into Spanish form, then in English the syntactic structure is noun produces adjective nominal, whereas in Spanish the rule is noun phrase produce nominal and adjective. So you need to have information of both of these syntactic rules, grammatical rules, okay? Then only you can perform the correct translation. Similarly, in case of like English to Japanese, so in English, verb phrase is follow means verb phrase produces verb and noun phrase. Whereas in Japanese, the rule is verb phrase produces noun phrase and verb. Means simply they are opposite of each other. So you need to have all this information. Okay, now what is statistical machine translation? This is the main thing actually. This is the core part of your machine translation, okay, which is included in your syllabus. So this one, the right part, like data driven based machine, means machine learning based machine translation, this yeah, machine translation. So what is that? Machine learning based means you need to have this statistical. We are not going to discuss about example based, we are going to discuss about statistical. Statistical means here we are going to discuss about probabilistic model for machine translation. Okay, yes. So here we'll discuss the points. Manually encoding comprehensive bilingual lexicon and transfer rules is difficult. This is we have seen, means manually converting one language into another is very difficult, very challenging. Okay, and SMT is what? Statistical machine translation. So SMT acquires knowledge needed for translation from a parallel corpus that contains the same set of documents in two languages. So what is parallel corpus? What is parallel corpus? Can anyone explain? Which is very important to understand because you will found this word very frequently in machine learning, having a parallel corpora. Parallel corpora means the definition is also written here, the same set of documents in two languages. Okay, so same set means same text in one language written into another language. Okay, so that is called parallel corpora. Okay, so for performing this statistical machine translation, you needed parallel corpora. And why this parallel corpora? How it is efficient? Because of this parallel corpora, you can create the word alignment. Right? Without the knowledge of word alignment, you cannot perform the machine translation. Okay, so first align the sentence in the corpus based on simple methods that use coarse cues like sentence length to give bilingual sentence pair. Yes, one more keyword you can find there, that sentence length. So it was found from the research that around 89% of the time in the parallel corpora, the sentences in source and target languages are having the same length. Same length means same number of words present in the source and target sentences. Means they are having one-to-one mapping, not one to many or many to one. Okay, this is very important to understand, that same sentence length. Sentence length means whatever sentence you want to convert from source to target language, it was found that 89% of the time in the parallel corpus you have same length of sentences in different languages. Okay, now noisy channel model. So this about this noisy channel model we have already discussed, and in the same lecture in the second slide we have discussed about this noisy channel model, that in this model we are trying to relate this machine translation with the cryptography. Okay, with the cryptography. So actually this noisy channel model are used as the basis for modern machine translation. So the idea was that we have a source signal. You can see here, source signal is English text. Look at here in this figure. Source is this one, right? And this is the target. So source signal in English form and the target signal is in some foreign language. F is representing foreign language and sometimes it is called as French language also. So French language is foreign language only, okay, for the person who does not know that language. Okay, so what is happening here? The idea was that we have a source signal that gets translated, means that gets transferred through transferred to our channel, and that's our mode of communication. So this is what mode of communication. Okay, and the noisy channel model is essentially a parametric probabilistic model of language and translation. Okay, so here using this communication model we are trying to translate one language into another. We will see how we are going to use this information. Okay, so one more thing is also written here, you need to focus on that. Translate foreign language F, which includes F1 to FM words, okay, into English sentence E cap E1 to EI, or I guess EL. Okay, so that means here you can see that may or may not be this M equals to L. Means may or may not be these these two languages are having, or these source and target sentences are having same number of words. Okay, and you need to maximize the probability of generation of English sentence when you have the given information for the foreign language. So here, and in the previous slide I have told you that when you want to perform the evaluation of the machine translation model, what you are supposed to do, you need to first you need to convert source into target, and for the evaluation you need to translate this foreign language back into the actual one. If so, when you will translate back, it will get E dash or E cap. Now you need to find how close this E dash with this actual E. If it is very close, then the probability will be very high and the noise will be low, and that means this conversion is correct. Okay, so for that reason we need to maximize this probability. This probability, maximization of this probability is nothing but we are trying to generate this E hat, which is need to be more closer to the actual E. Okay, now so the same thing is written here. Okay, so this model, this entire model can be understood like this. This is your encoder. Okay, encoder, and you have one decoder here. Because here we are trying to relate this model with noisy channel model. So here we want to translate E means English sentence into foreign language F. Okay, so that means encoder is trying to encode English into foreign, right? And then this decoder, what this decoder will do? Decoder will try to convert this F into this foreign language into actual language E, right? So this is going to be E hat or E cap. So that's why here this is E hat. We are trying to compute this E hat here. Okay, so for this one, for computing this E hat, what is the probability? How you can compute it? You need to perform this decoding, right? So for this decoding, you need to compute the probability of occurrence of sentence in English language given foreign language, isn't it? Means you have given foreign language and you want to produce English language. So for maximizing this, so this formula can be further simplified using the Bayes rule, and this Bayes rule is further simplified into this form. So here you need to understand this first form, this probability of foreign language given English language. So this encoder information. Okay, so this is what translation model. This is called as, this encoder is called as translation model. So here it is written now. This is encoding and called as translation model. Okay, and this one, probability of E, this probability of E input is given by the language model. So language model we have already studied how we can create the language model using n-gram model. Okay, so both the information is required here for generating the actual sentence. Okay, so here it is written, then use a standard n-gram language model for PE because here E dash this E hat is, what is the formula? Argmax translation model probability into language model probability. Okay, so language model probability you need to compute. So it can be trained on a large unsupervised monolingual corpus, right? Means आपको जब भी language model develop करना है, at that time you need to have a monolingual corpora, right? Either in English or in French. So if the source language is English, then you need a English language corpora for generating the language model. So this is one example to understand this logic, this one. Okay, so suppose the original sentence is written in English. This is what we were doing now. We were trying to convert English into French, or you can say foreign language. Let me write in French. Okay, so this translation we wanted to do. So in English sentence we must have some set of words. So if that word is this one, a flower red, so is it a correct sequence of word? So that information can be provided by the language model, whether this sequence of word is correct or not, is it meaningful or not. That information is provided by language model. Is it okay? Is it fine? Can you understand that, class?
Yes, ma'am. Yes, ma'am.
Yes, okay. So that means your input in case of translation, you must have some English words, and first you need to form a correct English sentence with that, and then you need to convert it into French form. Okay, so first you have some set of words. With that you need to form whether it is correct or not, whether it is a correct sentence or not. So first one is not correct. A flower red. This is not a correct phrase. So that means the probability given by your language model is very low, right? This is the language model, and this is what? Translation model. This is the translation model. Now, when you have given English phrase and you want to convert it into given French word. Okay, so that means now one more thing you need to understand. When you want to convert this set of words into French, then what is the basic requirement? You tell. Then we will proceed. What you need to have? Yes.
And this is statistical data.
No, okay, just don't think in terms of technical answer. Just answer me. If you want to convert any sentence from one language into another language, then how you can do that? You need to have some prior information about the other language, right? You need to have. Okay, so for that we are having parallel corpora. Na? We have discussed one thing, parallel corpora, parallel corpus. So parallel corpus means you have one model where you have some sentences. Suppose you have 100 sentences. So suppose my name is A. Okay, so some sentence is there. So the corresponding, so this is written in English, and the corresponding French translation is given to you. So this parallel corpora you already have. With this information, you will get the alignment. Okay, word alignment you will get. Okay, word alignment you will get that this word is aligned to this one. My name. So my is, suppose alignment is with A. Name is aligned with B. Okay, so this kind of information you already have. Okay, then only you can perform this translation, right? So now we are discussing the test case. Okay, this is the training information. So here we are discussing when the model is already trained and now you want to test. How you can do that? So that means at the time of testing, you must be having some sentence. And sentence is what? Sentence is composed of some set of words, some set of words. So first we will find whether this is a correct source sentence or not. So that information is provided here. Now, second is translation model. What your translation model probability is for that sentence means you have some corresponding alignment for these words. Now, from this parallel corpus, you can have corresponding alignment for these words. Means what is the corresponding French word for this one? But after that, what is the target? What is the correct sequence? What is the correct sequence for that French word? Okay, that information is going to be provided by this translation model. Is it okay? Am I clear? What we are? Yes. Okay. So first you need to clear in your mind that what we are trying to do here, what is input, what is output. Okay, just don't think in terms of implementation. Just think if you are the machine, how you are going to translate, how you are going to proceed, what you need to have, what is the input, what should be the output. Okay, so this should be very clear. Now you have some set of words in English, some set of words in French. Now you want to find what is the correct English sentence and what is the correct translation for this English sentence into French form. So that is going to be provided by the translation model. Okay, so here for the first sentence of flower red, language model is giving you low probability, but the translation probability is high. Why it is high? Can anyone answer? Yes. Why it is high? Because you already have this parallel corpora, and with this parallel corpora you can extract the corresponding word for each English word. Okay, and this is what you are trying to extract the probability of French word given the English word. Okay, so this is definitely going to be high. This is going to be high. Okay, so that's why the probability is high. But when you are going to multiply these two probability, it is low. Right? Now, for the second sentence, like red flower a. So again, probability means language model probability will be low because this is not a genuine sentence, not a meaningful sentence, and definitely this probability is going to be high. Why? Because you have corresponding words from the parallel corpora. Okay, and the probability is high, but the multiplication probability is low. Again, this is same thing for the third sentence. And the okay, now let's look at this one. A red dog. Red dog. So this is language model probability will give high probability for this one, because red is the property associated to this noun dog. So this is kind of correct sentence. Grammatically, syntactically, this is correct. So that's why language model is giving high probability for this one. Whereas for the previous three sentences, it was not high, it was very low. Okay, but the probability given by this translation model is low. Why so? Can anyone answer why the probability for this translation model is low? It is low because you are having a different word here, dog. Till that time, we had these three words. And for these three words, we have corresponding French word. But for whatever, and here, right now, we are trying to relate French of for a flower with dog, which is not going to be same. For that reason, the probability is low here. And when you will multiply low probability and high probability, the probability is going to be low. Similarly, for the next one, and finally, the last sentence is going to give you the correct result. A red flower. So the probability given by the language model is high, and the probability given by the translation model is high. So finally, the probability of generation of actual English sentence is high. Okay. So the same thing is represented here in terms of, same example thing is represented here in terms of model. You have the parallel corpora and the monolingual corpora for generating the language model. And for generating the translation model, you have a parallel corpora. Yes, this model is very important. You need to understand, okay? Parallel corpora is required for generating the translation model, and language, for generating language model, you need a monolingual corpora, okay? And what in the previous example we have discussed at this level, when you already have this parallel corpora and you have translation model, you have language model, then only you can perform the testing. Okay, I hope now it should be clear to you. Now we have discussed that IBM has provided the first translation model. Means IBM company has introduced in public the first translation model. Okay, so what they have given, they have provided a generative model based on noisy channel framework. So it generates the translation sentence E with regard to the given sentence F by a stochastic process. Stochastic process means probabilistic model they have. So they want to generate the first, means first you need to have the length of F. Length of F means the foreign language, whatever the foreign language sentence you have, you need to identify the length of F. Okay, and then you need to perform the alignment of E to the target sentence F. This is what we have discussed no here. I have, yeah, that example is removed. So I have told you that you need to identify the word alignment. Okay, so in the IBM translation model, they have focused on this point that you need to generate the alignment of E to the target sentence F. Now, finally, generate the words of F. Okay, finally, you need to generate the sentence in the foreign language. So these three are the main steps. So first, what is the first step? You need to identify the length of foreign sentence. So length is what? Length is constant term, right? So the constant term, we generally try to avoid that term. So that's why the probability for finding the length of foreign language is considered as constant term. Okay, and the alignment, as I have already told you that 89% of the time it has seen that the source sentence and the target sentence have same alignment, but means 10 or 20% of the time they are not aligned. So when they are not aligned, at that time it was seen that they are uniformly aligned. Okay, they are uniformly aligned. So that information we will see further how this is used. Okay, so first we'll see word alignment, how it can be done. Okay, so yeah, class, it's 3:10. So can I proceed further? I just want to finish this topic today. Can I proceed with the lecture?
Yes, ma'am.
Okay, maybe half an hour more. So I'll try to finish this topic, and in the next week I'll discuss different topic. Okay. Yeah. So word alignment. So directly constructing phrase alignment is difficult. Phrase alignment means, suppose you want to align one sentence with the other sentence. That is very challenging. You cannot do that. Even if you try to generate any machine for the phrase alignment or sentence alignment, you are never going to get the correct result. Okay, this is the uh, analysis of the researcher. Okay, so what you can do, you can perform the word alignment. Okay, so it can learn, means to align from supervised word alignment, but human aligned by text are rare and expensive to construct. Means there are supervised technique to perform the word alignment, and supervised technique means human based word alignment. Means suppose you are having some set of people who are expert in both the language, source and target language. So they will convert, they will tell which word in the source language is aligned to in the foreign language. Okay, so this human based alignment is very expensive and not at all feasible. Okay, so this is the challenge with the human alignment. Now, typically use an unsupervised expectation maximization based approach. EM approach means expectation maximization based approach to computer word alignment from unannotated parallel corpus. Means you have parallel corpus. Okay, you have parallel corpus, but they are not annotated. Means they are not aligned. That alignment can be done by this EM based approach that we will see. Okay, so now you understood that how many ways are there to perform the word alignment. So first technique is supervised word alignment, that can be done by humans, and second one is unsupervised based technique. So in the unsupervised based technique, the technique is EM based, expectation maximization based approach, right? So here one table is given, and with this table they are representing how the words are aligned in the source and target language. So this example is representing one-to-one and one-to-many and also reordering based word alignment. So this one, as it is already written source sentence, and the columns are representing target sentence. So in the source sentence, which is written in English, and the target is in French. So John and Zine. So this one means they have one-to-one mapping. They have one-to-one mapping. Now told has one-to-many mapping, because this told word is aligned to these two words. One-to-many mapping. Here you can also see one-to-many mapping, right? Now what this one is representing? Mary and this Amaria. Out of these three, what characteristic it has? It is representing reordering. Okay, this is reordering, and also one-to-many. Okay, now this is one-to-one, and for this story, the alignment is one-to-one. Similarly, here one more example. Yes, here one thing to notice is null alignment. Null alignment. Okay, so this example, this slide represents alignment for many-to-one words and missing words. So the words which are missing are aligned to null symbol. Okay, this is, I have already told you. Okay, sometimes you may have some words for which you are not having correct translation in the other language. So they are aligned with the null symbol. You need to remember this. Okay. So yeah. Now one more thing you need to remember here. You need to recognize here. Here with this table, we are trying to generate an alignment vector. Alignment vector. So these information is representing alignment vector information. Okay. So the first one is representing target position. So target is what? Target is this one, target language, and this is the source language. So in the target language, how many words you have? 8 words, right? 8 words you have. So that's why the size of this vector is 8. 1, 2, 3, 4, 5, 6, 7, 8, right? Now, and this is second row is representing source position. So here, this vector is representing word alignment. So the first word in the target language is aligned with first word in the source language. This is what it is representing. Okay. Now the second and third word in the target language, these two words, where they have aligned? They have aligned with the third. They have aligned with the third word in the source language. Okay. And similarly here, one-to-one mapping, one-to-one mapping, and these two words, 6 and 7, where they have aligned? Here with the null one. So that's why it is 0. They are aligned with the 0th word. Okay. And the 8th or the last word in the target language is aligned with the second word in the source language. Okay. So this is very important. This, why we have, whatever we are doing, that is going to play a vital role in further slides. Okay. This information is going to be used in generating a translation model. Okay. Now, yeah, this is everything we have discussed. Yeah, now we need to understand this model, probabilistic model, IBM translation model. Okay. So here, translation model with word alignment. So in the previous technique, we have not discussed anything about the word alignment. Simply, we were trying to generate the translation model. So here, one more element is added, and that is alignment. Initially, we had only these two terms, right? Now you have one more term. So this probability can be further means expanded into this form. Okay, so what are the things involved here? Yes, and in the just 2 or 3 slides back, we have discussed that when we are trying to generate model using this IBM technique, what they have told, first you need to find the length of the target sentence here, F, then you need to find the word alignment, and then you need to perform the translation. 3 things they have mentioned. These 3 are the main thing. So that means if you want to convert E into F, so you need to have some probable information about the length of the target sentence, which I have told you that we are going to consider it as constant. Now, next thing is word alignment information. Okay, how these two string of words are aligned, that information. And then the last one, which is translation of foreign language. Okay, means this is nothing but a translation model, which we have discussed in the previous slide. So this is only the previous information. Otherwise, these two are the new one. Alignment based information and the length based information. So let's see. Okay, yeah, so same thing is written here that here the length probability of M given E. Okay, so that is, we are going to consider it as constant because length is constant, so we are considering the probability is going to be constant for that one. Now alignment probability means what is the word alignment of the foreign language when you have given the words in the source language. So that is going to be uniform. I have told you that the word alignment is seen to be uniform at uniform distribution. Okay, so that is going to be represented by 1 by n. Okay, now let's try to simplify the previous expanded probability formula. So this was the formula, right? This was the formula we have seen in the last slide. This is what length probability, this is alignment probability, and this is translation model probability. Okay, so this is assumed as constant value epsilon, and this is what uniform distributions 1 by n plus 1. Why this plus 1? Because we add a null word, because for the missing word we are providing one more row, and that is null word. Okay, that's why plus 1. And why it is power is m? Because here we are performing multiplication from 1 to m. That's why this this power is here. And now you are left with only this translation model, probability of f given e, which we have already seen in the last slide, last example. Okay, so again one example is given for understanding this entire concept. So what was that? So first thing is what? First we are trying to encode the thing, and then we'll try to decode the matter, means message. Okay, so we are trying to relate the machine translation with the noisy channel model. So for that reason, first we are trying to generate the model. Generate means we are trying to encode the message. First we try to encode means we try to convert English into French. So English into French means first what are the things you need to have? You need to have the words in the English sentence. So this information is given to you. Null is added for some missing words. Okay, now for after that, what is the first thing? You need to identify the length of the target sentence. So what we have assumed, some constant. So suppose target sentence are going to have 8 words. After that we need to perform the alignment and then the translation model. Okay, so 3 steps are there. Length, you need to identify the length of the target sentence, word alignment, and the last is translation model. So first thing is done. Second is what? Alignment you need to find. So this alignment means from the parallel corpora you have this information. Okay, you suppose here right now we are using human based alignment model. Okay, so this information you are already having. Key target sentence, in the target sentence first word is aligned with the first word in the source sentence. Okay, so similarly for the other words. So now you are having this vector, alignment vector information. Now you want to perform the translation. So what are the information you are having? So English sentence, alignment and encoding. Okay, so with this encoding information, what is the encoding information? This one. So this encoding information you are sending. Okay, so 1 3 3 4 5 0 0 2. So what are the corresponding words are there in the source and target languages? So that is written, corresponding words. So third word in the English sentence is what? Across. That's why across is written. Okay. Okay. So that's how this data are going to be transmitted. This table is going to be transmitted over the communication channel, or you can say noisy channel model. Now, what is our target after that? At the time of decoding, first we try to generate the English sentence Okay, because when you are going to transmit, what was the target? We need to maximize the probability for the actual English sentence, right? So that we are going to do here at the starting. This one, language model for the English. From there you got this probability P of E. Okay. So here one more thing is given. P of E means probability of generating E when F is given. So this is what, if you remember, we have discussed in the previous some slides back, that at the time of decoding, we want to generate E hat given the information of F. So that is nothing but multiplication of these two probability. So this information you are already having from the language model, and this is from the translation model. So the probability is this one, and from that these two information you got this English sentence: John swam across the lake. Okay. Now again we want to retrieve the foreign sentence. Okay. So again the steps are same at the time of decoding. Again, whatever steps you have involved at the time of encoding, same steps you are going to follow at the time of decoding. Okay. So first you need to choose the length of the sentence, target sentence, that is here, and the probability is epsilon. Now the probability of the alignment is 1 by n, and finally you need to find this one and multiply. So here you can see that whatever you have encoded, the same sentence you have decoded. Okay. So this is represented for one example. Okay. So similarly, you can understand with the multiple examples also how it can be done. So for understanding it in more better way, you can try to implement this. And the code for the implementation of this machine translation is available on very easily. You can find the code in Python. Okay. And you can try to implement it actually. This is a good project work, I guess. Okay. Now decoding process in model 1. So actually in this one, decoding is require a lot of space. Okay, because you here English sentence length is unknown. Here we are simply assuming that the length is m or some constant value. Okay, so that are the challenges involved with the IBM based model. And all permutation of words in the vocabulary we are going to try, means for detecting the word alignment. Okay, so again this is a challenge. So this need to be solved. Okay, so the alignment, in terms of alignment, is like the generative process explains only one way of generating a sentence pair, and each way corresponds to an alignment. Means whatever, whenever you are trying to performing the translation, that is entirely depend on the word alignment. Okay, and for that you need, yeah, so the previous technique was based on the supervised based word alignment, and we have discussed that we have two types of technique for performing the word alignment. So one is human based, which is supervised, and the second one is unsupervised. So in this unsupervised technique, we are going to apply EM algorithm, expectation maximization technique. So in that case, the input is parallel sentence and the alignments are unknown, definitely, because for identifying the alignment, we are applying this technique. And the goal is to learn the model, means you want to generate the translation model. Okay, so what is written here? Estimation of translation probability. If we do not have ground truth word alignments, we need to explore the expectation maximization algorithm. So what intuitively guess the alignment based on the correct translation probability first and then update the translation probability. So actually, if you know what is expectation maximization algorithm, so in this one, first you have, so actually this EM algorithm have two steps, E step and M step. So in the E step, and since this is an unsupervised approach, so we know that in unsupervised approach, we are not having any prior information about the actual labels, right? So, how we can start this unsupervised approach? So for that, we need to initialize, है ना? We need to perform some initialization steps. So that initialization step is what? Here they are telling, guess the alignment based on the current translation probability and then update the translation probability. Okay, so this is the two step. First, you need to initialize the translation probability using some random approach. You have randomized algorithm for generating a random matrix. Okay, so using that information, you can generate the random matrix for the translation probability, and then using EM algorithm step, you can update the translation probability until you reach the achieved, or you can say when the further modification is not provided in the algorithm. So these are the two steps, E step and F step, E and M step, right? So initialize, this T is telling you about the translation probability between 0 to M. Using any random method, you can generate this probability matrix, okay? And then repeat the E and M step till T of F comma E value converges. Okay, so I hope you can understand what is happening here. So the formula is written in each step. What is happening for each sentence in training corpora? You need to compute C, F, E given F and E. This one. So what is this C of F comma E? Is the expected count that F and E are aligned. Expected count. So expected count you can get from the training corpora. Okay. So, and how this C of F comma E is computed? Using this formula. Okay. And yeah, first you need to compute this one. And now you have to use TF comma E. So TF comma E initially, it is some random value. Okay. So you need to use this information because while computing the C, you have this T of F comma E over here. Right? So that means when you are computing the C, means expected count, means how many times the words are aligned. That information is provided by CF comma E, means CF given E. So that is dependent on this translation probability. Okay. So that is already given initially with the random values. Now, so in the E step, you generate some C value, and in the M step, you are trying to update the value of T F given E. So in the in the M step, how the T F given E is updated? Using this formula. Okay, so this logic means this E step, M step can be understood in more detail at the time of implementation. Okay, so I hope the basics of E and M step is to be clear to you. Okay, right? I think this E and M algorithm we have used multiple places. In HMM also we have used this EM algorithm. Okay, right? So yeah. Now after generating this machine translation model, how you can evaluate it? So there are two types of evaluation, like machine based and the human based. So in the human based evaluation, first you check the fluency. So fluency means, is the result grammatically correct or not, is it understandable, and is it readable. Okay, so that means you need to have some humans who can understand both the language source and target, then only you can perform this. So what you can check: fluency, fidelity. Fidelity means, does the result correctly convey the information in the original source language? Means whatever we wanted to convey in the source language, is it, after translation, is it conveyed by the target language? So that is fidelity. Now adequacy is human judgment on a fixed scale. Suppose you have given a scale value like 1 to 10. Now, means at what level the human is going to judge that translation. So all this information. Now, in case of automotive or machine evaluation based technique, is like some scoring based technique. So these four technique is given like BLEU by this NIST, TAR, and all these techniques. Okay. Now the conclusion of this lecture is, empty methods can usefully exploit various amounts of syntactic and semantic processing along the vacuous triangle. Okay, we have already seen that triangular diagram, which is having all this information. Now, statistical machine learning methods can automatically learn a translation system from a parallel corpora. Okay, so means in case of a statistical method based machine translation, you need to have a parallel corpora, and typically use a noisy channel model to exploit both a bilingual translation model and a monolingual language model. And further, neural LSTM, means long short term memory methods, are currently the state of the art technique for this problem, machine translation. Okay, so LSTM is the state of the art technique for this problem. Okay, so I'll like I want to tell you that you try to implement this problem, then only you can understand the major challenges involved. Okay, so I'm going to stop the discussion over here. Is there any doubt from the lecture?
No, ma'am.
Okay, so I hope you got the idea how the machine translation can be performed and what are the challenges involved in this problem, right? Okay, Anirudh, can you stop the recording?
Okay, man.